Okay, is it this one? Welcome to class. Welcome to class. This one. Welcome to class. So I believe you can hear me now. Okay. Welcome to class. So I believe you can hear me now. Okay. Welcome to class. So I believe you can hear me now. All right, so if you're here right now, we just had to fix the sound issue. That's why I'm creating a new link. So join, I believe you're in the second link right now. Click on the second link. Click on the second link. All right. So check the second link. You should be hearing me right now. Please, I want to know if you're hearing me loud and clear before we begin. I want to know if you're hearing me loud and clear before we begin. Are you hearing me loud and clear? Are you hearing me loud and clear? I want to know if you're hearing me loud and clear. Are you hearing me loud and clear? Please, let's confirm. Are you hearing me? Are you hearing me? So if you're there right now, everybody join the second link. Join the second link. Okay, I'm just seeing a comment right now that you're hearing me loud and clear. You're hearing me loud and clear. Thank you so much. So we're about to begin. So the second link is what we are going with. All right. Loud and clear. All right. So I think we are set to start. So if you're there, you can share the link to as many as possible as you can, to as many groups as possible. We are about to start. And just before we start, again, I would like you to comment, what's your name and where are you watching from? While we join a few other persons. All right. What's your name and where are you watching from? Where are you watching from? We'd like to know you. Okay. We'd like to know you. What's your name and where are you watching from? I just hope you're here. Some persons are still going to join us, so I'm just giving a few minutes for them to do so. We are waiting for you. We are waiting for you. All right. We are waiting for you. Where are you watching from? I believe you're here with us. Let me just share the link to begin. All right. So in the next few minutes, we are starting. So get your writing materials ready. Get your pen ready. Get your books ready. Because we have begun already. And okay. Yes, Minima is hearing me perfectly. All right. From Ikotobasi, amazing. All right. Elijah from Abia State, we are waiting for you. You told me that you'll be here in this class. All right. We won't wait for so long. Okay. So if you are here, please, can you drop a like? If you have not subscribed to this channel, please subscribe. Drop a like, subscribe, and I can still give you some time to share. Share this link to as many as you can. Yes. So that they can be part of this video, so that they can be part of this interesting journey. Thank you so much. Thank you so much. Subscribe and share. Subscribe and share. All right. Subscribe and share. Okay. So we are live now. We are live now. All right, all right. So, get your calculators ready. Get your writing materials ready. Get everything you need to get ready. Get it ready. Get it ready. Because we have begun. We have begun. Okay, so I'm just waiting for a few more persons. And then we begin this interesting journey. Oh yes, we are almost there. So I hope your calculators are there. I hope your writing materials is there. I hope your book is there. I hope your note is there. I hope your pen is there. I hope everything is there. All right. And as we begin the class, please don't be distracted. Don't be distracted. This is not the time to be replying messages. I'm giving you time now so you can share and reply all the messages you think you should reply. All right. So all right. Okay. So one more, and then we begin. Your name, where are you watching from? Your name, where are you watching from? The Georgia Union, please engage in the comment section, please. Where are you watching from? Your name, where are you watching from? Your name, where are you watching from? All right. We are live now. All right. So I believe everybody is set because I myself, I am set. I am set. All right. Let's move. Please share the link. Share the links to as many as you can. Share the link to as many as you can so that we can begin. All right. So we are going to be starting on matrices. And just before that, for the last time, subscribe, click on the notification bell, and share this to as many as you can. This is going to be a very long journey. All right. If you have a question, please drop in the comment section. I'm monitoring the comment section. I will be seeing how I can reply or answer your questions in any place or part you have a problem as soon as possible. So thank you so much. Thank you so much. Thank you so much. All right. So the class begins. And so on matrices, we are started talking about matrices. That matrix is a rectangular array of numbers that can be enclosed within brackets. Rectangular arrays of numbers that can be enclosed within brackets. That when we have an array of numbers enclosed within brackets, that array or a list of numbers is called matrices. All right. So on that regard, we are going to be looking at some examples of this rectangular array of numbers. We're going to be looking at some of examples of that. And on the strength of that, I'm watching your comments to see if, all right, Ogolo Marvelous, I see you. Favor, I see you. Okay, ATSA, I see you. Ikotabasi, I see you. Okay, all right, we are still waiting for more persons to join. I see you, I see all of you. Samuel Okot, I see you. Samuno Liolua, I see you. Brendan Jr., I see you. All right. Please share the link to as many persons as you can, to as many groups as you can, as we begin. All right. So a rectangular array of numbers. So examples of that kind of array, I can have 2, 3 minus 5, 1. This is a rectangular array. And I can also have 1, 3, 5. Yes. These are examples of matrices. I can also have 7, 0, and 4. So following up from what we are doing, because I know that majority of also a good number of those, some of us here, were not here when we had started a foundational class on matrices. So what you are seeing here is a rectangular array. Every matrix has a horizontal relationship called row and vertical relationship called column. So these are rows and these are columns. So this matrix has 2 rows and 2 columns. So you can call this a 2 by 2 matrix, a 2 by 2 matrix. The by multiplication is used to represent that. And for this, how many rows? I can see 1 row, and I can see 1, 2, 3 column. So this is a 1 by 3 matrix. This is a 1 by 3 matrix. This is a 2 by 2 matrix. So if you look at this matrix, I'm having 3 rows, 1, 2, 3, and 1 column. So this matrix is a 3 by 1 matrix. So this is just a scratch of matrices. So these are the types or examples of this rectangular array of numbers which we are talking about. All right. A matrix with only 1 row is called a row matrix. For example, this is a row matrix because that's just 1 row. And a matrix with only 1 column is called a column matrix. Like this one is a column matrix because that's just 1 column. All right. There are so many things we can talk about in matrices, but because of how elaborate matrices are, for the sake of this class, we are going to be concentrating on the jump aspect of matrices. We're going to be concentrating on the jump aspect of matrices. I'm planning that I will make a video that will cover some other aspect of matrices for the sake of those that are writing further mathematics in their WAEC, because some areas in matrices is not captured in jump. Those areas are a bit deeper for those of us doing further mathematics, which are going to write that in our theory exams. So for the sake of this class, we're going to be focusing on the objective aspect or the jam scope of matrices. So let's take notes as we proceed. So when we're talking about matrices, we can talk about a square matrix. A square matrix is a matrix that has the same number of rows and the same number of what? Columns. For example, this is a 2 by 2 matrix, 2 rows and 2 columns. So a square matrix have the same number of rows and columns. So a 2 by 2 matrix is a square matrix, 2 rows and 2 columns. A 3 by 3 matrix is a square matrix, 3 rows and 3 columns. 3 rows and 3 columns. And we also have a 4 by 4 matrix, a 4 by 4 matrix that is 4 rows and 4 columns. So at some point, we'll be looking at 2 by 2 matrix, and at some points, we'll be looking at 3 by 3 matrix, especially determinants. And a 4 by 4 matrix is beyond the O-level scope of matrices. That is considered in the A level. For those of us studying mathematics as courses in the university, and also engineering as course in the university, we look at 4 by 4 matrix. So for the sake of this class, we're going to be focusing on 2 by 2 matrices and 3 by 3 matrices. Let us move on. So there are different operations in matrices which we are going to be looking at. Victor Isaiah from Ikotobasi, I'm seeing you. I see you. Victor Isaiah, I see you. I see you. All right. And we're still waiting for more persons to join, but we have to proceed. We can't wait for you for so long. So moving forward from there are different operations in matrices which we can consider. And one of those operations is addition of matrices. Another is subtraction of matrices. Another is multiplication of matrices as well as what? Division of matrices. So we're going to pick it together, addition and subtraction of matrices. Let's look at the addition and subtraction of matrices. 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 In addition and subtraction of matrices, we're going to see how we can add this rectangular array of numbers and how we can subtract this rectangular array of numbers. For example, if a matrix A is given by 3, 1, 2, 5, and a matrix B is given by 2, 3, 1, 1. So I can ask you to find matrix A plus B. I can ask you to find matrix matrix A minus B. A plus B, A minus B. Addition and subtraction of matrices, it is no big deal at all. It's no big deal at all because A plus B, this is a 2 by 2 matrix and this is a 2 by 2 matrix. This matrix is of the order of 2 by 2. This matrix is also of the order of 2 by 2. Remember what 2 by 2 means? 2 rows and 2 columns. The first value stands for the row and the second value stands for the columns. All right, proceeding from there, we would see that A plus B, that's the I, simply means that I should add these two. Addition of matrices is just very cheap. So the first element in this matrix, you're going to add it to the first element in this other matrix. So A plus B will be given us, so that will be 3 plus 2. All right, the next that is going to be 1 plus 3, and then this is going to be 2 plus 1, and then this is going to be 5 plus 1. So A plus B, please be following. All right, 3 plus 2, that will give me 5. All right, and 1 plus 3, that gives me 4. 2 plus 1, that gives me 3, and 5 plus 1, that gives me 6. All right, so A plus B is giving us a matrix 5, 4, and 3, 5, 4, 3, 6. So that is very simple, adding a matrix of the same order. I hope you know that this is a square matrix and this is also a square matrix. All right, let's look at A minus B. A minus B. For A minus B, we'll perform the same operation. This will be 3 minus 2. This is 1 minus 3. This is 2 minus 1. This is 5 minus 1. So from there, we are going to have that. So A minus B. 3 minus 2 is 1. 1 minus 3 is minus 2. 2 minus 1 is 1. And 5 minus 1 is 4. So A minus B is 1 minus 2, 1 and 4. 1 minus 2, 1 and 4. All right, so I'm just, okay, Njanabasi, I see you. Inemesi Tumo, I see you. All right, and okay, Savior, I see you here. I see you. So I'm just trying to read a message. So it said, hello, sir, please, since we have enough time, can we make it can we make it more calm? All right, that has been noted, Sir Savior. I'm going to make it a bit more calm, okay? That I'm too fast, all right? So I want to emphasize, for the sake of Savior, we're not going to do math in one. I hope you know that, okay? So we will do math, we'll do physics, and we'll do chemistry, all right? So we have time, but we don't have time, okay? So, but I'll be calm. I'll be a bit more calm, all right? I'll be calm. Let's proceed. Let's proceed. Thank you for those of you that are following. So we've looked at something on addition. We've looked at something on subtraction. Let us look at multiplication. Let's look at multiplication of matrices. So if you were writing something down, I believe that by now you must have jotted down something. Is there any question before I proceed? Samuel Ukot, you cannot be sleeping right now. You can't be sleeping right now. This is a very important and strategic moment. Please put your legs inside water. Wash your face, put your leg inside a basin of water so that you don't sleep. And if possible, be standing. Yes. Yes. So that you will not sleep. It may be as if you die now, but don't worry. Nothing will happen. You will not die. Eh? You understand me? Let's continue. Let's continue. All right. All right. So we move. Multiplication of matrices. Multiplication of matrices. All right. In multiplication of matrices, we are going to look at two aspects of that multiplication. We are going to look at scalar multiplication. And we are also going to look at matrix multiplication. Matrix multiplication, I like calling this the dot product. So in scalar multiplication, which is what we're going to treat first before we move to matrix multiplication or the dot product, you can see with me that a scalar, from what we know in physics, a scalar has magnitude but no direction, but a vector has magnitude and direction. When we're looking at scalar multiplication, we're looking at a matrix that just have one row and one column. Or, I prefer this definition. A scalar is just talking about a single element in matrices. A scalar just talks about a single element in matrices. So that's a scalar. For example, so scalar multiplication is when a single element is multiplying a matrix. What do I mean by saying that a single element is multiplying a matrix? What I mean is that a single element multiplies a rectangular array of numbers that is closed within brackets. What I'm saying is that a single element multiplies a rectangular array of numbers that has rows and columns. For example, if A, so scalar multiplication is what we're looking at now. If A is equals to 2152, all right, 2A, find 2A. What do I mean by saying find 2A? It means carry 2 and multiply by A. This 2, this 2 is a scalar because it is not a rectangular array. It is not, it's a single element. All right? It's a single element. So from there, we can say that this is 2 multiplied by my A was 2152. So when a scalar is multiplying a matrix, what I have is that each of the elements in that matrix will be multiplied by that scalar. So what do I mean by that? So 2A right now means 2 times 2, which is 4, 2 times 1, 2, 2 times 5, 10, 2 times 2 is 4. All right. So 2A is given as 4, 2, 10, and 4. This is scalar multiplication. This is scalar multiplying a matrix. Scalar multiplying a matrix. All right. So, Idagogo, I'm seeing you. Okay, it's going well. I'm happy. I'm happy that it's going well. All right, all right, all right. Thank you so much. Let's proceed. So if there's a question, you can drop it in the comment section. I'm monitoring the comment section. I'm monitoring the comment section. All right. What do we mean by matrix multiplication? In matrix multiplication, we are looking at a matrix multiplying another matrix. For example, A is equals to 2, 1, 5, 2, and B is equals to 1, 3, 5, 1. So find AB. Find AB. To find AB simply means pick this and multiply by this. In matrix multiplication, you know, some persons will be tempted to, because you are asked to find AB, to do something like this. And see what is happening now. If you look at what is happening right now, someone will say 2 times 1, 2. 1 times 3, 3. 5 times 5, 25. 2 times 1 is 2. No, 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 no. You don't do that. This is matrix multiplication. For scalar, you can carry 2 and multiply everything. But for scalar, you don't do it that way. All right? You don't do it that way. Sorry, for matrix multiplication or dot product, you don't do it that way. All right? So how do I go about this? The rows will do what? Multiply the columns. I repeat myself. The rows will multiply the columns. So AB will be 2 times 1. 2 times 1 plus 1 times 5. 2 times 1 plus 1 times 5. That is for the first position. The next position will be, this row will multiply this column. That is what? 2 times 3 plus 2 times 3 plus 1 times 1. Now, I need some space. That's why I'm cleaning that. All right. So I am done with this position. I am done with the next position. I need some space. The same thing I'm going to write. All right. So for the next position, I will say this row, the second row will multiply the first column. So that's 5 times 1 plus 2 times 5. That's for that position. The next position will be 5 times 3 plus 2 times 1. All right. So AB will become 2 times 1 is 2 plus 1 times 5 is 5. 1 times 3 is 3 plus 1 times 1 is 1. 5 times 1 is 5 plus 2 times 5 is 10. 5 times 3 is 15 plus 2 times 1 is 2. So you can see that from there, I now have that my AB is 7, 4, 15, and 17. So that is AB. So make sure you're following. Make sure you're following. Brandy, thank you so much. You're finding the class interesting. Thank you so much. Thank you so much. All right. So I'm just seeing a question from Idagogo from the scalar multiplication. Where did I get the 2 from? I was just giving an example of a question like that. You can be asked, so this is a question. If A is equals to this, find 2A. All right. So I'm just giving an example question. I'm talking to Idagogo. All right. So it's just a sample question. I don't know if you're following me. Just a sample question that I'm giving. All right. So this is matrix multiplication and this is scalar multiplication. I know that some persons may not find the matrix multiplication very friendly. Don't worry. We are coming back to the matrix multiplication or the dot product. All right. I have a jam-pass question which I want to present to you that will talk about the scalar multiplication, that will talk about the addition of matrices and or the subtraction of matrices. We are going to come back to matrix multiplication. Let's look at this jam-pass question. All right. So the past question says, if you are with your pen, you can write it down. You can write it down. So I don't know if you have a past question with you. I'm looking at 2015 number 20. Is it 215 number 20? Yes, let's check it out. That should be the year. Yes, yes. So I'll read it out. I'll read it out. I believe that by now you should be with your pen, you should be with your writing materials. The question says, if P is equals to, I hope you're with your pen, I hope you are writing that. Akani in ATSA, where did the 2 came from? The 2 is a sample question I'm giving to you. Okay, it was just a sample question. All right. It can be 2, it can be 3, it can be anything. So look at this question. It would explain more on that. It will explain more. So the question says, let's go. If P is equals to 5321, 5321, and Q is equals to 4235. If P is equals to 5321 and Q is equals to 4235, find 2P plus Q. Find 2P plus Q. Find 2P plus Q. Find 2P plus Q. Option A, 814, 77. Option B, 77, 814. Option C, 14, 8, 77. Option D, 77, 14, 8. All right, so we are to find 2P plus Q. If you are paying attention, okay, Dimit Basi, I think the reason why you have not seen it is maybe the question type, the 2015 type you have is different from the 2015 type that I have. All right, so that's what I'm seeing here in my 215. All right, it's possible that they are different because of different types. I mean, number 20. But if you have not seen it in your own past question, the question is on the board. If P equals to 5, 3, 2, and 1 in those positions, Q is 4, 2, 3, and 5 in those positions. Find 2P plus Q. So the question is on the board. The question is on the board. All right. So Victor, you said you don't understand matrix multiplication. Don't worry, we are coming back to that. Let us finish scalar multiplication and addition and subtraction of matrices. This question captures it. We are going back to matrix multiplication. All right. Okay. So for this, moving forward, we have 2P plus Q. So in Agogo, you can see that this 2P, this matrix now, in some questions it can be 3P. It means that you carry 2, multiply everything inside P. If it was 5, if it was, okay, let's solve this. Let's solve this. So solving this, we would now have 2P. 2P will give us 2 into 5, 3, 2, 1. It mustn't be 2. It's because of the question. That's why we're picking 2. So this is 2 times 5, 10. 2 times 3, 6. 2 times 2, 4. 2 times 1, 2. So 2P is giving us this. Plus Q. Plus Q. So 2P plus Q means 10, 6, 4, 2. 10, 6, 4, 2 plus Q. Q is 4, 2, 3, 5. Remember, we must add. So in adding, I've told you when you're adding, you can respectfully pick this and add to this. So this is 10 plus 4. This is 10 plus 4. All right. And this is 6 plus 2. And then this is 4 plus 3. And then this is 2 plus 5. This is for addition. You know that in matrix multiplication, we don't just add it like that. We don't just add it like that in matrix multiplication. We don't just multiply like that when it's matrix multiplication. You know that. We will look at matrix multiplication again anyways. So 2P plus Q will give me 14, 8. This is 7 and 7. So you can see that. You can see that. 14, 8, 7, and 7. So the correct answer for option is option C. Option C. So I believe you can do that. So Akani HSA, I am going to give another example of matrix multiplication. Don't worry, we are coming there. Okay, so this is that on that example on matrices. There are many other questions that can come from scalar multiplication or addition or subtraction of matrices. Of course, you know, if this was minus, you know what to do there. So let us proceed because of our time. Moving forward from there, we are going to look at matrix multiplication again or dot product. Let's begin. And for matrix multiplication, I will just explain it in another way. If I have a matrix A as A11, A12, A21, A22, and matrix B as B11, B12, B21, B22. These are the elements in A. These are the elements in A. And these are the elements in B. Now listen up. If I say find AB, find AB. In finding AB, I will use the rows and do what? Multiply with the columns. What do I mean? the result of this will be a 2 by 2 matrix. So for the first position, and I'll have another, and I'll have another, and then I'll have, another. So this position will be what? A11 times B11 plus A12 times B21. I hope you're there now. A11 times B11 plus A12 times B21. For the second position, I will use this first row and multiply the first row in the first matrix A and multiply the second column in the second matrix. So this will be A12 times B12 plus A11 times B12 plus A12 times B22. So for the second position, I'll use the first row and multiply the second column. All right, you can see this position here. I am going to, since I've stepped down, I'm going to step down too. I'll go to the second row. I'll use the second row and multiply the first column. So that will be A21 times B11 plus A22 times B21. If you notice what is happening, you are having row times column, row times column in this systematic form or way. So for this, I would move to the next column and I will say A21 times B12 plus A22 times B22. So that will give you the second position. You use the second row and multiply the second column to give you a matrix in that position. So this is how we find the dot product or matrix multiplication, especially for a 2 by 2 matrix. All right. I said number 20, 2015 number 20. If you have not seen it, the question was on the board. So please, let's proceed. Okay, I'm giving another example. All right. Basi, Dimit Basi, just follow us. You are going to get this. Follow us. All right. So moving forward from there, I will see what kind of an example. So let me give another example. If A is equals to 1521 and B is equals to 3123, all right, find AB. So find AB means, so AB will be 1521 into 3123. So I will apply this rule. So the rows will multiply the what? The columns. So for the first position, AB will be equals to, so this is 1 times 3, which is 3, plus 5 times 2, which is 10. I've gotten that for the first position, all right? For the second position, I will use this row and I'll multiply this column. So this will be 1 times 1 plus 5 times 3. But 1 times 1 is 1. 1 times 1 is 1. So I will just write the 1 plus 5 times 3 is 15. So I'll just write the 15. I've gotten the second position. So, and for this, I would say 2 times 3, that's A21 times B11. A21 times B11, that's 2 times 3, which is 6 plus, and then A22 times B21. All right, A22 times B21. So that will now be 1 times 2. 1 times 2 is 2. All right, so this will be, I would step to the next column. So for this position, it will be A21 times B12. A21 times B12. So it will be 2 times 1, which is 2, plus 1 times 3, 1 times 3, which is 3. That's A22 times B22. So that is that. So AB will now be equals to 3 plus 10 is 13. 1 plus 15 is 16. 6 plus 2 is 8. And 2 plus 3 is 5. So you can see that. You can see that that has been done on matrix multiplication, or you can call it dot product. I am still waiting for a question if you have any on that. If you have any on that, 42339. I love that. I love that. Thank you so much. All right. So if you still have a question on matrix multiplication, please put it up in the comment section so that I will know whether I should move forward or I should still dwell on that. Thank you. I give a few seconds for someone who may be jotting down 1 or 2 because I'm about to proceed. I'm about to proceed. In the absence of any question, we move. All right. So that matrix multiplication is specifically for a 2 by 2 matrix. Before we proceed, let me just tell you 1 or 2 that you need to know about matrix multiplication. In matrix multiplication, a matrix AB is defined if and only if the number of columns in matrix A is equal to the number of rows in matrix B. I repeat, a matrix AB can only be defined if the number of columns in matrix A is equal to the number of rows in matrix B. A matrix AB is defined if and only if the number of columns in matrix A is equal to the number of rows in matrix B. If the number of columns in matrix A is equal to the number of rows in matrix B, matrix AB is what? Defined. If the number of columns in matrix A is not equal to the number of rows in matrix B, then matrix AB is not defined. Idagogo, you said the matrix is not still clear. What is not clear? What I advise you to do is keep watching. Just keep watching. It is going to be clear. All right. So there are a few to talk about in this matrix multiplication, but because we are just picking major areas that may interest us in the JAM examinations, which is coming up, that is why I am deciding to not go into so much details on this matrix multiplication. For example, matrix multiplication is not commutative. It's not commutative. I can't talk about the commutativity now because of our time. Let us move now to the determinant of a matrix. The determinant of a matrix. The determinant of a matrix. In the determinant of a matrix, we are going to look at the determinant of a 2 by 2 matrix, and we'll look at the determinant of a 3 by 3 matrix. Determinant of a 2 by 2 matrix. What do you mean by determinant? Determinant, in a layman understanding, is the overall magnitude of a particular matrix. The overall magnitude of a particular matrix. So for a 2 by 2 matrix, if matrix A is equals to A11, A21, A12, A22, all right, the determinant of A can be written as DETA, or you can write it this way. Determinant of A can be written as that. You can also say that the determinant of A, which is this, can also be written as A11, A21, A12, A22. You can use this symbol. Okay, to signify the determinant. So moving forward from there, for a determinant in that general form, so determinant of A, which is A11, A12, A21, A22, is given as A11 times A22 minus A21 times A12. What is going on there? This is called the principal diagonal in matrices. So the product of the principal diagonal minus the product of the other diagonal gives you the determinant of a 2 by 2 matrix. So this is the principal diagonal. And from there, we can see that is how to find the determinant of a 2 by 2 matrix. This other diagonal is the other diagonal. All right. So a perfect example of this, I think I have a past question here on these matrices. But just before that, I don't want to mention it here because I don't know, the questions I may have here may not be exactly the same questions that you may have there. All right. So let us look at this question. Let's look at this question. But before that, if I have a matrix, if I say that a matrix A is 5 minus 1, 3 minus 2, what is the determinant? If I say find the determinant of A, how will I do that? It's simple. The determinant of A will be 5 times minus 2 minus 3 minus into 3 times minus 1. Don't say minus 3 times minus 1. 5 times minus 2 is minus 10. Minus into 3 times minus 1 is minus 3. See what the determinant will be? 5 times minus 2, minus 10. 3 times minus 1, minus 3. So the determinant will be minus 10, minus 10, minus 3, that's plus 3. So that gives me minus 10 plus 3, that is minus 7. So that will be the determinant of A. So for a 2 by 2 matrix, that is how to find a determinant. I have a practical question here, which I would like us to treat on determinant of a 2 by 2 matrix. I believe I can clean. So the question says, I won't read it out for you. I will just write it on the board. Okay. It says, if this means determinant. If the determinant of this is 15, find the value of x. A 2, B 3, C 4, and D is 5. What is the value of x? Now, this question combines determinants with equations. The first thing to do is to find the determinant on the left-hand side and equate it to the right-hand side. When I do that, my principal diagonal, that is x times 7, solution, x times 7 minus 2 times 3 gives me what? 15. X times 7 gives 7x minus 2 times 6. 2 times 3 gives 6 equals to 15. That gives me 7x. Remember, I want to make x to stand alone. Minus 6 will cross over, and it will become plus 6. And that will now become 7x equals to 21. To find x, I'll divide both sides by 7, so that x equals to 27 over 1, so x is equals to 3. So the correct answer is B, that the value of x is 3. The value of x is 3 in that particular question. It's down. Okay. So you can look at that. Drop the question if you have a question. Drop a question again. Okay. No. Use the code that's of that power bank. Okay, Akani, the question I'm having here is 2. You can solve yours, that is 4. All right? And check your options. The question I'm having here is 2. So let's proceed. Okay, you said the answer is 2. No. Check. You check again. Akani, check again. Huh? Yeah, it's. I don't think it's the question that I'm doing. So Akani, I don't think it's the same question that you're talking about. What do we like it? Okay. Okay. No, it's not. Yes, it's good. On the power bank. It's like the phone was not full. The phone was not full when you started. All right, let's proceed. Let us look at the determinant of a 3 by 3 matrix. For a 3 by 3 matrix, if A is A11, A12, A13, A21, A22, A23, A31, A32, A33. The first thing you're going to do is that you assign cofactors. Cofactors is a positive or negative sign attached to each of the elements. So this is plus, this is minus. 1 plus 1 is 2. When I add the row and when I add the nth row and the nth column, if it gives me even, the cofactor will be positive. I add the nth row and the nth column, if it gives me odd, it will be negative. So this plus this 4 is even, that's positive. 2 plus 1, 3, odd, this will be negative. This will be positive. This will be negative. This will be positive. This will be negative. This will be positive. Those signs that I'm attaching to each of those elements is called the what? Is called the cofactor. So to find the determinant of a 3 by 3 matrix, the first thing I want to know, do you want to use the first row, or you want to use the second row, or you want to use the third row? You can use any of the rows. Do you want to use the first column, or you want to use the second column, or you want to use the third column? Any of the ones you want to use will give you the same answer. The first thing you need to know is the cofactors, which I've just done. The next thing we need to know is the what? Is the minor. So if I'm using the first row, I need to find the minor of the first row. So imagine I'm using the first row. These are the elements in the first row. These are the elements in the first row. I need to find the minor in the first row. How do I find the minor? The minor of a particular element of the determinant order of n is obtained by deleting the row and the column of a particular element of a determinant order n, so that a determinant order n minus 1 is obtained. What do I mean? If I want to find the minor at this position, I will say that A11 is equal to what? I will delete this row, I will delete this column. So what is left? What is left is A22, A23, A32, A33. The determinant of what is remaining gives me the what? The minor. If I want to find the minor of this position, I will use capital letter A12 to denote the minor. That will be the determinant of what? Delete this row, delete this column. So what do I have left? A21, A23, A21, A23, and this is A31, A32. A31, A33, sorry. So for this, I deleted this row and I deleted this row. So what I have left is A21, A23, A31, A33. The determinant of that is the minor. And then A13. To find the minor for this position, I delete this column, I delete this row. What I have left is A22. What I have left is A21, A22, all right, and A31 and A32. I'll find the determinant of that. A11 is a minor, capital letter A11 is a minor of the elements in small letter A11. Capital letter A12 is a minor of the element small letter A12. Capital letter A13 is a minor of the element small letter A13. Remember, we are using the first column. So we are going to attach to find the determinant. So if I want to find the determinant now, I will now say that the determinant of A will be given as the minor here is plus. So I'll now say plus A11 times capital letter A11. The next is what? Minus the minor here, minus the element is A12 times the minor of that position. capital letter A12. The cofactor plus the element is A13 times the minor of A13 is capital letter A13. Okay, let me put it this way, times A13. This is how to find the determinant of a 3 by 3 matrix. This is how to find the determinant of a 3 by 3 matrix. So you take note of that the first I need to know the cofactors, plus, minus, plus. I can decide to use the cofactors in the second column. If I'm using the cofactors in the second column, that means I have to find the minor here, find the minor here, find the minor here. You know how to find the minor? Delete the row, delete the column, and then find the determinant of what is remaining. That is how to find the minor. I can decide to use the third column, the third row, to find the determinant. It will give you the same answer. I can decide to use the first column, I can decide to use the second column, or I can decide to use the third column. But whatever I use, I need to find the minors of each of the elements present. Let us look at a practical question on determinant. All right, so the question said, evaluate, I'm going to write it. So I believe by now you should have gotten this. Evaluate this symbol just means determinant. So if I'm using the first column, my cofactors, plus, minus, and plus, so my determinant would be, I'll pick the first element, which is plus 2. I'll cross this column. What I have left is what? The determinant of 6391. If you can see what is happening there, 6391 is the minor for this first position. I cross this, and I found the determinant of that. A11 is my plus 2, and the next minus 0. I cross this. So what I have left, if I cross this and cross this, I have 4381. 4381. So that will be, that's okay. I still have one more, plus 5 times. So I'll cross this. What I have is 4689. I cross this. 4689. Find the determinant of that. So from there, I move. So the determinant, I don't know if I gave you options. I would like to give you options before I continue. So option A was minus 102. Option B was minus 42. Option C is 18. And option D is 102. All right, let's proceed. So the determinant will now give us 2 into determinant of that 2 by 2 matrix. 6 times 1 is 6, minus 9 times 3 is 27. The next is minus 0 into 4 times 1 is 4, minus 8 times 3 is 24. And plus 5 into 4 times 9 is 45. 4 times 9 is 36. minus 8 times 6 is 48. So that determinant will be 2 into 6 minus 27 is minus 21, minus 0 into 4 minus 24, whatever it is, minus 20. 0 times anything, of course, you know that this one will go, it will go up, all right? Plus 5 into 36 minus 48 will be minus 12. So what I'm going to have, 2 times minus 21 is minus 42. This is 0, has gone. Plus 5 times minus 12 is minus 60. Minus 42 minus 60 is minus 102. Is minus 102. And moving forward from there, we can see that the determinant for that 3 by 3 matrix is minus 102. If you're not careful, there is how you can solve this, and then you are having 102. At this point, I will be entertaining questions in 3 by 3 matrix. I'll be entertaining questions if you have. Okay. Okay, I'm seeing Clement here. Dami Nambo, he said that you are having understanding issues. Okay, and Basi, you're still having problem understanding 3 by 3. All right. All right. Mighty Ekanem, I'm just seeing your question. I'm just seeing your question. All right, I'm just seeing your question. Now, if you are having an issue understanding this, look at this. I am through this again. Cofactor starts with plus. This is minus, plus, minus, plus, minus, plus, minus, plus. In that, listen. I love to use the first rule. I was using the first rule. This plus 2, that's the plus 2 I'm having there. This minus 0, that's the minus 0 I'm having there. This plus 5, that's the plus 5 I'm having there. For this one, I cross this column and I cross this row. Basi, watch. My name, watch. What am I having left? I'm having 6391. I'll find the determinant of that. After that, I'm at 0 now. After that, I'm at 0 now. So what happens here now? If I cross this and cross this, what do I have left now? What I now have left is 4, 8, 3, 1. I cross this and cross this. 4, 3, 8, 1. That's how I have that. I'll find the determinant of that. The next is the third element, plus 5. And I cross this and I cross this. What I have left is 4, 6, 8, 9. That's how I have that now. I'll find the determinant of this. What exactly is the problem? Is it find the determinant of that 2 by 2 matrix and multiplying it by the element you have in that position? What's really the problem? Or is the problem with the cofactors? Is it that you don't understand what I explained about cofactors? Please, I'm waiting a few seconds for you to type in what really is the question. The purpose of this class is that you get to understand what we are doing, what really is the question, so that I can go through it again. Dimit Basi, I'm waiting for you. What really is the question? Is it the cofactors you don't understand? Is it the minus you don't understand? Or is it that you don't know how to find the determinant of a 2 by 2 matrix? Oh, Mighty Ekanem says it's clear. I'm so grateful. I'm so grateful that it is clear to you now. I'm so grateful that it's clear to you now. Glory to God. All right. I'm waiting for Basi. Basi, what is really the problem? What is really the problem? Is it the cofactors? Is it the minor? What exactly is the problem? So that I see how I can help you out right now. I just hope that people are not sleeping here. Please, if you're still active, indicate by a comment. If you're still active, indicate, please. All right. Okay, Clement says it's clear now. If you are still active, please indicate. Pastor Victor Toby is here. I'm just seeing your message. Thank you so much, sir. Thank you so much. All right. Thank you so much, Pastor Victor Toby. Thank you so much, sir. It's an honor to have you here on my channel. Thank you so much. Thank you so much, sir. All right. The next, economy is active. All right. So I want us to move to the next thing now. Determinant. Let's move to adjoint of a matrix. The adjoint of a matrix. And because of this, I am going to be specifically talking about a 2 by 2 matrix. I'm going to be talking about a 2 by 2 matrix for adjoint, because 3 by 3 matrix, especially for those of us that are doing further math, writing further math in WIEC. So I may create a video differently, not a live class for those kinds of students. But we are going to just be looking at a 2 by 2 matrix. So I believe I can wipe the board now. All right. Adjoint of a matrix. For a matrix A, equals to A11, A12, A21, A22. The adjoint of A is denoted by, just change the position of the principal diagonal. Change the position of the element in the principal diagonal. When you change the position of the element in the principal diagonal, the next thing you do, so that will now become A22 and A11. Just change the position of the element in the principal diagonal. And then A12, you attach a minus sign to it. And A21, attach a minus sign to it. This is the adjoint of a 2 by 2 matrix. Okay. Is it working now? All right. Yes, I could see. I see it's pausing. Okay. So we are back now. Sorry for the interruption. It was beyond us. That has to be rectified. So I believe we can continue from there. So I believe we are good. We are good to go. We are good to go, right? Hello, are we still there? Are we still there? So let's finish this so that we make a quick switch to physics. All right. Are we still there? Are you with me? All right, please, let's continue. Let's continue. Let's continue. Let's continue. So please, let's come back. We have begun. We have begun. Let's us continue. If you're sleeping, you're wrong. Let's proceed. All right. So the next question, the next thing we want to look at is the adjoint of a matrix, and then we look at the inverse of a matrix, and then we make a quick switch right now. Okay. Okay, it's stable now. Oh my God, I love what I'm seeing, man. All right, it's stable right now. Okay, so let's move. Let's move. Let's move. Okay, so for this particular question, for this particular subtopic, the adjoint of a matrix, in finding the adjoint of a matrix, example matrix A, A11, A12, A21, A22, we are just making a quick switch. In switching this, A22 comes here, A11 comes down there, and then we attach a minus sign. We attach a minus sign over there. So that is how to find the adjoint of a matrix. So if I'm given a matrix, A is equals to 2 minus 1, 3 minus 5. Adjoint of A will be what? Exchange the element in the principal diagonal. That will be minus 5. I'm exchanging the element. Minus 5. And this is 2. Then here will be minus into minus 1. And here will be minus 3. Make it come out a bit more polished. This will be minus 5, minus 3. Minus minus is plus 1. And this is 2. So this is the adjoint of A. That is the adjoint of A. All right? All right. So if you have a question on adjoint, please feel very free. Exchange that position. Attach a minus sign. I exchange the position. I attach the minus sign. Minus into minus 1 is plus 1. Minus into 3 is minus 3. We move. Let us look at the inverse of a matrix. Finally, before we switch to physics, the inverse of a matrix. I'm looking at the 2 by 2 matrix. Looking at the inverse of a 3 by 3 matrix will take us into a very deep journey, which we may not finish this night. So we're just looking at the jam scope. The inverse of a matrix A is denoted by A raised to power minus 1. Or you call it A inverse. So what does this mean? The inverse of a matrix, A inverse, is given as 1 over determinant of A times what? The adjoint of A. 1 over determinant of A times the adjoint of A. This is something I'm saying that the inverse of a matrix, 1 times the adjoint, is the adjoint of A all over the determinant of A. The adjoint of A all over the determinant of A. That is the inverse. So from there, we can say that A inverse, yes, A inverse is given as that. I have just taught you how to find the adjoint of A, and I have taught you already how to find the determinant of A. Let's look at this past question. Please, I am reading the question that I have here. So if I read the question for you, the question I may have may not be the same question as you have. You can solve the question you have at your spare time. All right. So we are still on track. This question is very, I love this question so much because of the way this question is presented. The question goes, so you can write. The question says, if P is equals to 2 minus 3, 1, 1. If P is equals to 2 minus 3, 1, 1. 2 minus 3, 1, 1. What is, let me write it this way. What is P raised to power minus 1? What is P inverse? Or what is the inverse of P? Solution. The inverse of P is simple. The inverse of P, so P inverse will be 1 over determinant of P times the adjoint of P. All right. What is the determinant of P? This should not be a problem at all. Determinant of P is the same thing as 2 minus 3, 1, 1. Let's find the determinant. That will be principal diagonal, 2 times 1, 2, minus 1 times minus 3, 1 times minus 3, minus 3. So that gives me 2 minus minus 3. And 2 minus minus 3 is given as 2 plus 3. And 2 plus 3 is given as 5. So first of all, we need to find the determinant of P. And then we'll now find the adjoint of P. We'll find the adjoint of P. So let's find the adjoint of P. Don't forget that formula, because it was P, I didn't use A. I didn't use A because what I'm given was P. All right. So moving from there, I now have that the adjoint of P is equals to this is what will happen. Change the position. That is 1, 2, and put a minus sign, minus 1, and minus into minus 3. That will be the adjoint. So the adjoint of P will give me 1, minus 1, 3, and 2. 1, minus 1, 3, and 2. 1, minus 1, 3, and 2. So from there, P inverse is 1 over determinant of P was what? It was 5 times the adjoint of P is 1, 3, minus 1, and 2. So you can have a quick write-up if you, I don't intend to be too fast, all right? My apologies if it's as if I'm moving too fast, all right? So from there, I would now say that this is the same thing as P inverse, that's 1 over 5 into 1, 3, minus 1, and 2. If you notice what is happening here, this is scalar multiplication. That means this scalar multiplies each of the terms inside our matrix. So that will be 1 over 5 times 1. It will be 1 over 5. 1 over 5 times 3. It will be 3 over 5. 1 over 5 times minus 1. Minus 1 over 5. 1 over 5 times 1 over 5 times 2 is 2 all over 5. It's 2 all over 5. Meanwhile, we need to do a quick check in that question so that we can be sure that we are not making any mistake. We need to be sure that we're not making any mistake. All right. Okay, so having looked at that, I think we're on track. So I believe you have jotted this down for those of you that need it. So that is my inverse. It will interest me to give you the options that we had. That's the options that we had. So what we had as options was option A. I know why I'm writing these options. You need to be careful when you're choosing options. Option A was minus 1 over 5, minus 3 over 5, minus 1 over 5, minus 2 over 5. Option B was 1 over 5, 1 over 5, 3 over 5, 2 over 5. Option C was minus 1 over 5, 3 over 5, minus 1 over 5, 2 over 5. Option D, if you look at these options, I know why I'm writing these options. It resembles this thing. It resembles this. But it is not. Look at what we have as our answer. And look at what we have in the options. It's not exactly the same. It's not exactly the same. They look like the same. The only place I have a minus sign is here. And here I'm having minus sign in 2 places. Here I'm not having a minus sign at all. Here I'm having a minus sign in all the 4 positions. And look at option D, 1 over 5, 3 over 5, minus 1 over 5, 2 over 5. Yes. So you can see that the correct option is option D. It is not A, it is not B, it is not C, but D. All right. All right. So let us proceed. Let us proceed. What is adjoint? I just saw a question right now. Somebody asking what adjoint is. And I can't remember who the name, the person, the name is. But whenever you hear adjoint in a matrix, I'm just answering a question I saw right now. Adjoint is also called the adjugate matrix. Another name for adjoint is adjugate matrix. Yes, it is a new matrix formed from the cofactors of the original matrix and then transposed. My God. Adjoint is also called the adjugate matrix. It is a new matrix which is formed from the cofactors of the original matrix and then transposed. So I'm trying to answer that question. So when we're talking about adjoint, another way you can define adjoint is adjoint of A, for instance, is given as cofactor of A transposed. Transposing the cofactors of A. All right? When I say transpose, the transpose of a matrix is a matrix in which the rows become the columns and the columns become the rows. Yes. If that explanation does not help you so much, We will meet in the physical class. I know you're one of my students. I will explain that better to you in the physical class. We need to push right now because of the constraint of time. Just remind me in our physical class. I'm gonna explain that to you better. But just know that it's also called the adjugate matrix, and it is a new matrix formed from the cofactors of the original matrix and then transpose. Let us have a very quick switch to physics. Before I make that quick switch, I'm going to drop a question for you. Which I expect that you should attempt. Maybe not now, but in our physical classes. But if you can attempt it now and give us an answer, I will check and I will confirm it. All right? And the question goes, I know that some students here are writing WAEC, so there's no harm in giving this question. This question, I think I saw it 1 year like that in JAM. All right? Not exactly, but something like this. The question says, if A is equals to 21 minus 30, and I is a 2 by 2 unit matrix. Evaluate. Do you know what you're evaluating? See it here. You're evaluating a square minus 2a plus 4i. You're evaluating a square minus 2a plus 4i. So when I say that I is a 2 by 2 unit matrix. A unit matrix is a type of matrix in which the major diagonal is 1. Another name for a unit matrix is an identity matrix. An identity matrix is noted by I. If I say that I is a 2 by 2 unit matrix, that means this is what I is. You can see the principal diagonal. The principal diagonal is 1, and then the other diagonal is 0. This is a 2 by 2 unit matrix. This is a 3 by 3 unit matrix. See a 3 by 3 unit matrix here. 1, 1, 1, 0, 0, 0, 0, 0, 0. You can see the principal diagonal is 1. This is a 3 by 3 unit matrix, and this is a 2 by 2 unit matrix. Another name for unit matrix is an identity matrix. So in the question which I'm giving to you, this I is a 2 by 2 unit matrix. You see this a square? It means you should square this. It does not mean 2 square, 4, 1 square, 2, minus 3 square, 9, 0 square, 0. No. You are going to use matrix multiplication. Carry this, multiply by the same again. So matrix multiplication, a square means a times a. That means 2, 1 minus 3, 0. All right? And this is 2, 1 minus 3, 0. So you're going to multiply this using matrix what? Multiplication. Use the row, multiply the columns, and you know how to do that in that exercise which I am giving to you. Yes, so this is an exercise. It's an exercise. So you can do it, drop answer on the comment section, or you can send it to a DM for me on WhatsApp. My WhatsApp number is on this page. All right. And moving from there, we can proceed. Cut off this one. Was the video interrupted? Okay. All right. So let's make a quick switch to physics. We spend so much time on mathematics. Let us switch. Our target is 1 a.m. So we still have about 1 hour and 30 minutes. We still have about 1 hour and 30 minutes. So I believe we are good to go. All right. Let's move to physics. So I believe you have gotten this question right now. I believe you have gotten that. So in physics, we are moving to simple AC circuits. Simple AC circuits. What do I mean by simple AC circuits? The word AC refers to an alternating current. AC refers to an alternating current. So if you know a physics student right there, please tell that student that we have begun. We have begun. All right? We have begun. Akanyene is yawning. Please, we have 1 hour, 30 minutes left. Stay with me. Stay with us. All right? Those of you that have started with us and now you're sleeping, you are wrong. Wake up, wake up, wake up. All right? Okay, so you can put your legs inside water. Put your leg inside water, wash your face so that you don't sleep. Yes. Endure it. You may look as if you will die, but you will not die. Eh? Nothing will happen to you. Let's proceed. All right. So in the next 1 hour, 30 minutes, we can do something very reasonable. In simple AC circuits, what is very paramount to us, what I am so concerned about in this simple AC circuit is the major areas that you may likely see question from. The major focus or part that we are concerned with as far as the class is still concerned. Okay, Victor Bell, you don't have to sleep. No, you can't have this class in your dreams. Please come back to the physical realm. Put your legs inside water. Nothing will happen to you. You will not die. Eh? If you were watching movie, you know you would have been watching movie till 4 a.m., 5 a.m. You see now like this class. You can testify to what I'm saying. So please stay awake. Stay awake. You can do this. You can do this. Exactly 1 hour, 30 minutes left. So let us move to simple AC circuit. So please wake up, wake up, wake up. All right. Moving from there, what do we mean by simple AC circuits? I started by saying that AC means alternating current. AC means alternating current. An alternating current, to start with, is a type of current that varies sinusoidally. It's a sign of current that varies sinusoidally or periodically in such a way as to reverse the direction periodically. In such a way as to reverse its direction periodically. So an alternating current varies sinusoidally. What I mean by varying sinusoidally, it means that it changes sinusoidally. A sine graph in mathematics moves like this, starts from the origin, goes like this, goes like this, goes like this. Moves in this direction, moves in this other direction, moves in that direction, moves in this other direction. So you can see sinusoidally. On the vertical axis, I can talk about the voltage or the potential difference or the current. On the horizontal axis, I talk about the time. So an AC current varies sinusoidally with time. And in addition with that, this variation or these changes, all right, happens periodically. And the direction keeps reversing, goes this way, reverses, goes the other way, you know. That's the most standard definition of an alternating current. The elementary definition of alternating current that you know is that an alternating current is a current that flows in two directions. Direct current flows in one direction. Alternating current flows in two directions. But this is a more holistic or complete definition. The vertical axis is V or I, and the horizontal axis is always time. The current is given by IO sine WT, where IO is the peak value of the current, and where I is the instantaneous current. I repeat, where I is the peak value of the current, sorry, where I is the instantaneous current, where IO is the peak value, peak, another name for peak is maximum value of current. Maximum value of current. Peak value of current or maximum value of current. Esther, don't allow that sleep to worry you. To be as if you die, but you will not die. Please put your legs inside water. All right, so the board is shaking. Okay, I'm going to make sure the board doesn't shake. I'll try and see how the board can be a bit more stable. All right. Because it is a sign, this graph varies sinusoidally. WT is what I call the phase angle. WT is what I call the phase angle. And from waves and from simple harmonic motion, we know that W is equals to 2 pi f. That means that the instantaneous current is equals to IO sine 2 pi ft. So everything here is an angle. So the sine of that angle multiplied by the peak value of the current is what we mean by, that will give us the instantaneous current. The instantaneous current is the current at any instant in time. The peak value of the current is the highest value, the highest value that this reaches, all right? If I am looking at voltage, the peak value of the voltage of VO is the highest value of the voltage. This equation can also be as V equals to VO sine 2 pi ft, where V is the peak value of the voltage or the maximum value of the voltage, and where V is the instantaneous voltage. And then this is peak or maximum value of voltage. Now, there are so many things I'm going to talk about now on this simple AC circuit, but I'm just picking up, not everywhere, but major parts or areas. All right. There's a term called RMS value. RMS value of current. RMS current. RMS means root mean square. Root mean square current. Root mean square current is denoted by IRMS. Remember, we have I, which is the instantaneous current, the current at any instant in time. We have IO, which is the peak or the maximum value of the current. And then we have IRMS, which is the root mean square current. What then is a root mean square current? What then is a root mean square current? Pick up water and wash your face. You can't sleep now. The root mean square current is that steady current which will develop the same quantity of heat in the same time and in the same resistance. The root mean square current is a steady current which will develop the same quantity of heat in the same time and in the same resistance. The root mean square current is a quantity of heat that will develop, is a steady current which will develop the same quantity of heat in the same time and in the same resistance. The root mean square current, or IRMS, is given as the peak value of the current divided by root 2. Another way you can represent that is that the root mean square current IRMS is given as 1 over root 2 times the IO. 1 over root 2 times the IO. If I rationalize, I can say that IRMS is IO over root 2 times root 2 all over 2. Root 2 all over root 2. That's if I rationalize. From there, I would have that IO root 2 all over root 2 times 2 is what? 2. How did I get here? This is where it started. I just rationalized times root 2 all over root 2. IO times root 2 gives us IO root 2 divided by root 2 times root 2 is 2. Don't forget what IRMS is. It is the steady current that will produce the same quantity of heat in the same time and in the same resistance. That current is at root mean square value of the current. And that's the formula for calculating the root mean square value of the current. Don't forget the peak value of the current or the maximum value of the current. It is the highest value of the current. Don't forget the instantaneous current. It is the current at any instant in time. And that current is noted by IO equals to that. Don't forget the instantaneous voltage. It is the voltage or the potential difference at any instant in time. Don't forget the peak value of the voltage is the maximum value of the voltage in the course of progression of that current. And don't forget that there's also something called VRMS. That VRMS is VO all over root 2. If I rationalize, that will be VO root 2 over 2. That is from my rationalization. Let's pick a past question on simple AC circuits before we proceed on into what other things that we have. All right. Nikonjushi is asking, sir, can I sleep? You can't sleep. Why don't you say the class is over? It's just about 1 hour and 20 minutes left. You just have about 1 hour, 20 minutes left, and we will be done with the class, right? So I don't know why you want to sleep by this time. If it's really necessary, are you sure? Tomorrow is Saturday, so stay tuned. Stay tuned. All right. You're doing something to yourself. You're doing something to you're stretching yourself. All right. This is training beyond the class. This is training. You don't know what it is doing to you. You're going to see that later. So I advise you stay. Thank you so much. All right. Let's take this question on simple AC circuits. The question says, find the RMS value of an alternating current whose peak value is 5 amps. I clean? Find the RMS value of an alternating current whose peak value is 5 amps. Find the alternating find the RMS value rather find the RMS value of an alternating current whose peak value is 5 amps. Yes, Yakubu, manage. You have to be there. So beyond management, we are doing something beyond management. All right. Thank you so much, Mighty Ekanem. Please stay awake. So from there, we move. The RMS value of an alternating current is what we are looking for. Is root 2 all over, is IO all over root 2. Sorry for the shaky board, manage with me. From there, the peak value in this question given. I am given that the peak value, which is IO, is 5 amps. And I'm asked to find the RMS value. IRMS will be given as IO, which is 5, all over root 2. Sometimes, especially for an objective exams, you'll be required to leave this answer in short form. So sometimes you'll be required to leave it in short form. The meaning or the implication of that is that I'm going to rationalize. So this is 5 all over root 2 times root 2 all over root 2. That will mean that IRMS will give me root 2 times root 2. So that's 5 root 2 all over 2. You can leave it this way, or you leave it like this, 2.5 root 2. Or you find the value of root 2, multiply by 2.5, all right? That will give you 3.53 approximately 3.53 amps. This will be the root mean square value of the current. What does that mean? It means that the current we have just found is a steady current which will produce the same quantity of heat in the same time and in the same resistance. It will be this value of the current. Let's proceed. The second question, which we are going to treat, says, at that point, if you have a question, you can just let me know where you have the problem. 1 hour, 15 minutes to go. We are making progress. Please stay tuned. Don't sleep. Don't sleep. There's something I want to say for those that are going to stay awake. But let me not say it now. Let's continue. I will not say it now so that. All right. The second question. In an AC circuit, the peak value The next question. If you sleep by mistake, wake up again and continue the class. Just seeing a comment right now. In an AC circuit, the peak value of the potential difference is 180 volts. What is the instantaneous potential difference when it has reached 1/8 of a cycle? What is the potential difference when it has reached 1/8 of a cycle? Oh my God, thank you, Brandy. Thank you, Brandy, for that comment. That means someone is really following us. What is the instantaneous potential difference? Instantaneous potential difference is referring to the instantaneous voltage. How are we going to do that? So, meanwhile, we need to write down the formula for instantaneous voltage. That is, V is VO sine WT. Remember that this is the phase angle. Everything in there is the first angle, all right? And this can also be written as E, in terms of EMF, that will be EO sine WT. This should not confuse you at all, all right? So from there I have that the peak value of the potential difference is 180. That means that E is equals to 180 sine when it has reached 1/8 of a cycle. The angle theta here, which is the first angle, is talking about 1/8 of a cycle. A cycle is 360 degrees. 1/8 of 360, 8 goes here, 1/8 goes here, 4, remainder 4, 8 goes here, 5. 1/8 of a cycle simply means 1/8 times 360, that is 45 degrees. This means that the first angle, WT, that WT is 45 degrees. That is sine 45 degrees. You have to find the instantaneous potential difference. That is V, or the instantaneous voltage. So that is 180 times sine 45. Sine 45 is √2, is 1/√2, which is √2 over, yes, √2 over 2. So E will be 2 goes here, 1, 2 goes here, 90. So what I'm going to have will be 90 √2 volts. That will be the instantaneous voltage, 90 √2 volts, or you can find the value of this and give a more expressed answer. Okay, Nikonjushi, are you part of my physical class? If you're part of my physical class, optics as a topic will be done in an all-day class. That will be next month. 1 week to your exams, in an all-day class. That's when I'm going to do optics. That's even in my physical class. That's when we'll do optics. We're not going to do optics in our online class because optics, we need enough time to dissect and bisect and insect. You understand what I mean? So let's continue. So if you start class, that will be a week to the exams, and all day, start from morning, we'll just be doing optics. So let us continue. All right. So I need to look for practical questions on this for you. But before this, let's look at other concepts in simple AC circuits. I'm talking about going straight to the formulas. I don't have much of the time to do much of the explanations in some concepts which I'm supposed to go a bit more deep. So we'll just get the formulas and see how we can make progress with this. So the next thing I want to talk about is the reactance, the impedance, and the impedance in an AC circuit. The reactance and the impedance in an AC circuit. Before I talk about the reactance, and there is something called reactance, and there's something called impedance. And as far as that is concerned, we have XC and we have XL. I believe I can wipe this now. Okay, Ariana Kim, yes, you're going to see the class. You're going to see the class after the live class is over. If your battery percent is low, you can always view it later. But if your battery percent is not low, I advise you stay to the end of the class. You see the reason why I advise you to stay to the end of the class. Those of you that are going to stay to the end will testify. All right? Okay. All right. So from there, there is something called reactance. Reactance can be divided into capacitive reactance and the inductive reactance. The capacitor does the function of storing charges. But in an AC circuit, the capacitor also resists the flow of charge. Reactance simply means the opposition to the flow of an AC offered by a capacitor or an inductor or both. The resistance or the opposition offered by a capacitor or an inductor or offered by the both of them. I repeat myself, the reactance in an AC circuit is the opposition offered by the capacitor or offered by the inductor or offered by the both of them. If the opposition is offered by the capacitor, that kind of opposition is called the capacitive reactance. When I say opposition is it just means resistance. That means that reactance, which can be divided into capacitive reactance and inductive reactance, is measured in what? Ohms. Is measured in ohms. And there is something called impedance. Impedance is denoted by Z. Capacitance is denoted by X. Reactance is denoted by X, and reactance is denoted by X, and impedance is denoted by Z. Now, from there, we can say, I'm in a live class. From there, we can say that these two are oppositions. They are both resistances. The unit of this is in ohms, and the unit of this is also in ohms. It's very important to note that. Now, an inductor does not primarily does the work of opposing charges, but In an AC circuit, when an inductor is inserted in an AC circuit, that inductor somehow will oppose the flow of charges. So an inductor stores energy in the form of a magnetic field when electric current flows through it. It stored energy in a magnetic field when electric current flows through it. But in an AC circuit, that inductor at the same time will oppose the flow of charges. Capacitive reactance, which is denoted by XC, has a formula, and the formula is 1 over 2 pi Fc. This is the frequency, this is the capacitance. The inductive reactance has a formula 2 pi Fl. This is the frequency, this is the inductance. The unit of capacitance is in farad. Capacitance is in farad. And the unit of inductance is in Henry. Sometimes you see other units, microfarad, you have to convert it to farad. You may see microhenry, you have to convert it to Henry. So, reactance is the opposition offered by a capacitor. I will have the capacitive reactance, or by an inductor, I have the inductive reactance, or by both of them. That is what reactance means. Their unit is in ohms. Why? Because this is an opposition. It's a type of resistance. Let us look at impedance. What is impedance? Impedance is the overall opposition of a mixed circuit. The overall opposition of a mixed circuit offered by a resistor, an inductor, and or a capacitor. That resistance offered, that overall resistance offered by a resistor, an inductor, and or a capacitor. So the resistance offered by a resistor, a capacitor, and or an inductor. What does this mean? The difference between reactance and impedance is that reactance involves resistance by a capacitor or resistance by an inductor or the both of them. But an impedance involves offered by a resistor and resistance offered by a capacitor. It also means resistance offered by a resistor or resistance offered by an inductor. It also means resistance offered by a resistor, a capacitor, and inductor. It can involve the three of them. It can involve the two of them. It can involve these two. But there must be a resistor. If you notice, in reactance, there's no resistor. But in an impedance, all right. So we are back now. We are back now. We are back now. And that was network. That was network causing serious interruption. All right. All right. Okay, let's us move fast because we just have about 45 minutes to go. All right. I advise you stay till the end. Okay. All right, so I don't know where we stopped. I don't know where you were caught up. I don't know if you were there when I explained the impedance, that's opposition offered by a resistor, a capacitor, and or an inductor. That the difference between an impedance and reactance is that an impedance involves opposition by a resistor and by a capacitor and by an inductor, or by a resistor, capacitor alone, or by a resistor and an inductor. But for a reactance, reactance involves opposition by a capacitor and an inductor, or capacitor only, or inductor only. So we take notes on that. The Precious, thank you so much for welcoming me back. Thank you so much. We are back and we move. Thank you. Thank you so much. Esther, thank you so much. All right, let's move. Now, the formula for capacitive reactance, that's the opposition offered by a capacitor, is given by 1 over 2 pi Fc. And the formula for inductive reactance is 2 pi Fl. You may be given a question and then you'll be asked to calculate the capacitive reactance. Unit of this C is capacitance, which is in farad. Unit of this L, which is an inductance, is in Henry. These two formulas respectively can be used to calculate the capacitive reactance and the inductive reactance. All right. Before we go, before we push, I feel we should solve a question on this, just to help us understand this formula. For example, looking for a perfect question that will help us. Take this, take this, take this, take this. All right. The question says, at what frequency, at what frequency will a 20 microfarad capacitor have a reactance of 500 ohms? A 100 over pi, B 50 over pi, C 50, D 100 pi, E 30 over pi. So our answers are in terms of pi. So you can see there, what frequency will a 20 microfarad capacitor have a reactance of this? Now you can see that this is a capacitor. This reactance is this one. So they have given as 500 ohms. They have given capacitance as 20 microfarad. You need to convert from 20 microfarad to farad, which should be 20 times 10 to the power minus 6. This is micro. To convert it to farad, you multiply it by times 10 raised to the power minus 6. So you have to find the frequency F. The formula I'm going to use XC, using XC equals to 1 over 2 pi FC. That will give that XC, which is 500, 1 over 2 pi times times 20 times 10 raised to the power minus 6 farad. I want to find F, so I cross multiply. That will be 500 times 2 pi times F times 20 times 10 raised to the power minus 6 is equal to 1. Is equal to 1. What am I looking for? I'm looking for F, which is the frequency. So this is 500 times 2 pi. That is 1000 times F times 20 times 10 raised to the power minus 6 equals to 1. To make F to stand alone, multiply 100 pi times this. 100 pi times 20. 100 pi times 20 will give you, sorry, 1000 pi times 20 will give you 20,000 pi. So what I have is 20,000 pi times 10 raised to the power minus 6 times F. So this will be, because my options are in terms of pi, this will be divide both sides by 20,000 pi times 10 raised to the power minus 6 divided by 20,000 pi times 10 raised to the power minus 6. That will cancel. That will cancel. So what I have left is that my frequency is 1 all over 20,000 pi times 10 raised to the power minus 6. In power minus 6 is something as indices. This is something as 1 times 10 raised to the power what? I believe you can see what is happening there now. 10 raised to the power 0 is 1. So this is something as 1 all over 2,000 times 10. This divided by this raised to the power 0 minus 906. You can see that now. Indices is playing out again. So this is F is equals to 1 times 10 raised to the power minus minus is plus 6. Minus minus is plus 6. Yes. 0 plus 6 all over 2005. So this is 1 times 10 raised to the power 6, 2005. So this is 10 raised to the power 6 all over 2005. So what 10 raised to the power 6? I believe that by now you must have gotten this question. Yes. So I won't clean the options. 10 raised to the power 6 is something as 1 million all over 2005. 0 comes to 0, 0 comes to 0 up, 0 comes to 0, 0 comes to 0 up. So my answer now becomes 1000 over 2 pi. 1000 divided by 2 pi, 1000 divided by 2 pi, that will give us 100, 2 goes here, 50, 500 all over pi. 500 all over pi. So the correct answer is 500 all over pi. 500 all over pi. Yes, that is our answer. 500 all over pi. Look at the option. We are not having 500 all over pi. The mistake we made was that when multiplying, my voice is not cracking over here. I don't know why the voice is cracking. All right. Okay. All right. Let's check it again. It's still cracking. It's my phone. All right. So I think the voice will be better now. All right. So if you look at it, you need to be very careful. 1000 pi times 20 is not 2000. 1000 pi times 20 is actually what? 20,000. So we need to observe that is 20,000 pi. We need to observe that 20,000 pi. 20,000 pi. 20,000 pi. So this is 20,000 pi. This is 20,000 pi. Remember, 1,000 times 20, 1,000 times 20 is 20,000 pi. All right. So this is 20,000 pi. Here we have 20,000 pi. Here we'll also have 20,000 pi. So you can see the correction of now. So that's 20,000 pi. All right. So three zeros cancels, zero cancels, zero. So you can see that now. So this will now be 100 divided by 2 pi. Yes. So 2 goes here, 1, 2 goes here, 50. You can see there. So that is 50 all over pi. So from there, my answer is A, 50 all over pi. 50 all over pi. So the correct answer, no, not A, the correct answer is B. The correct answer is B. 50 all over pi. So if there is the part you don't understand, please let us know. I don't think the voice should be cracking right now anymore. I just changed the mic I was using. So if you have a question so far in what that question that we have treated, please let us know. Let us know. Let us know. Thank you for that observation. You can check it up again. Vasi, you're feeling sleepy. We are ending the class in 24 minutes. So hang on, hang on, hang on. All right. So is there any question so far? Because in the absence of any question, I want to proceed. All right. Let us move to another important concept AC circuit. So questions can come that will involve you to use XC equals 1 FC or XL, where L is the inductance equals to 2 pi FL. Take note of this: capacitive reactance and inductive reactance. Very important formulas. Okay, let's look at impedance. Impedance. What is impedance? Impedance, as I've said, is the overall operation a resistor and a capacitor, or a resistor and a inductor, or a resistor, inductor, and a capacitor. Impedance Z is given as square root of R squared, square root of R squared, plus XL squared minus XC squared. This is the square of the inductive reactance minus the square of the capacitive reactance. Correct me? Correct me. This is all square. Let's correct ourselves. All right. This is the capacitor. Sorry, the impedance. The impedance is also given as square root of R squared plus this is 2 pi FL minus this is 1 over 2 pi C, 2 pi FC, rather, all square, all square. All right? And take note of that for impedance, the overall opposition. resonance in an RLC series circuit. R for resistor, L for inductor, C for capacitor. What do I mean by this? What I am referring to is that resonance, which is a very important concept, resonance is said to occur when the maximum current is obtained from the circuit. Current is given as V all over R. Current is given by V all over R. And in AC circuits, this R will be the impedance, which is Z. To have the maximum current in this circuit, it means that what? It means that I need to have the minimum value for the impedance. To have the maximum value for the current, the impedance, lower the impedance, the higher the current. So for maximum current, I need the lowest value of the impedance. For lowest value of the impedance, everything here has to be 0. So that I don't have R left. This may not really make sense to you. But what I want you to think, so what I want you to remember is that for maximum current to be obtained from the circuit, that circuit must be at what? Resonance. And at resonance, XC is equals to XL. What I mean is that the capacitive reactance must be equals to the inductive reactance for resonance to take place. Because when the capacitive reactance is equal to inductive reactance, and I do that subtraction, that will be what? 0. And it's only R squared I'm going to have. And that will give us the least value for the impedance. And when we have the least value for the impedance, we have the highest value. So the condition for which maximum current is obtained from the circuit is that the impedance must be the least value. And for the impedance to have the least value, the capacitive reactance must be equal to the inductive reactance. So for resonance to occur, capacitive reactance XC must be equal to the inductive reactance XL. The condition for which resonance must occur is that XC is equal to XL. That is the end point of this discussion. And one of the things you need to know is the frequency at resonance. The frequency at resonance. What is the frequency? Frequency. So when XC is equal to XL, at resonance, frequency is denoted by FO. That means if XC is equal to XL, it's still cracking. I don't know. Yes. Don't know what the cause could be. I think the video is even blurry itself. I don't know if it's blurry on their side too. Right. Where is network? It's network. Yeah. Check if it's still blurry. If it's still blurry, it's network on your own end. Over here, it's very clear. It's very clear over here. I think it's network from your own end. Okay, it's now clear. It's now clear. All right. Okay, we have 25 minutes to go. You can do it. You can do it. 25 minutes to go. So, you want to find the resonance frequency, the frequency of resonance. That's the frequency at which the inductive reactance equals to the inductive reactance. Remember, at resonance, they must both be equal. And at resonance, maximum current must be obtained. At resonance, maximum current to be obtained from the circuit, the impedance must be minimum. So, resonance frequency, you take the inductive reactance and the inductive reactance of formula. Cross multiplying what we have, making f the sum of formula, you can see that I am moving 2 pi times 2 pi, that is 4 pi square, f square, L C. I want to make f the sum of formula, so I divide both sides by 4 pi square L C. And divide both sides by 4 pi square L C. So doing that, 4 pi square L C, 4 pi square L C comes. So I have that 4 pi square L C equals to f squared. That means that f squared equals to 1 over x squared LC. Make this formula out. Square, take the square root of both. Square cancel square root. So f is equal to square root of 1 is 1. Square root of 4 pi square LC. That will give me square root of 1 is 1. Square root of 4 is 2. Square root of pi square is 5. And then square root of LC. I have simplified the square root of 4 pi square. Give me 2 pi. Square root of 1 is 9. So f equals to 1 over 2 pi root LC. This frequency is called f of the code, which is the resonance frequency, which is the frequency at resonance in an AC circuit. All right. So from there, also say, if you notice, you discover something. If I take this 2 pi here, I have 2 pi f equals to 1 over root LC. Well, you can remember that this is what? This is W, which is the first angle. W, which is the first angle. All right. This, which is the first angle, you can also say that that is what? WO is equals to 2 pi FO equals, which is equals to 1 over root LC. Where there is a inductance, where C is the. All right. So this is the angular velocity, the angular velocity at resonance. This is the frequency at resonance. Well, as we begin to make questions, we see how important these formulas are. Because questions are very important. So you can be given a question and then you have to find frequency at resonance. You can be given a question and then you have to find the inductive reactance using the formula. So these formulas are very instrumental. This we can talk about in simple basic. I'm just taking major formulas, major areas and formulas that we can on these areas. So in our outside classes, we'll be looking at more advanced questions on simple AC circuits. So at this point in time, we have just 20 minutes left. Let us make a switch in chemistry. Just 20 minutes left. So before we make that switch, if you have a question so far, you can drop it before we go into this quick journey in chemistry. So in chemistry, we're supposed to look at IUPAC nomenclature, and then we talk about esters. We are going to do that very briefly. We're going to do that very briefly, right? We will not spend so much time there because we need to go by 1 a.m. Stay tuned. All right. Okay. Yeah. We just left the last part. Oh good. Okay. My Twitter name. You will meet me in the physical class. We will talk about it. Yes. Sonobo Nathaniel, you don't understand the last part. I didn't see this message on time. I would have explained it again. I'm sorry about it. In our physical class, we would talk about it. All right. So let us move straight to chemistry. IUPAC nomenclature. We have just 15 minutes left. We have 15 minutes left. Thank you. So, IUPAC nomenclature is the IUPAC name. IUPAC name. You can see this compound. What's the IUPAC name? You can see this compound. What is the IUPAC name? All right. So, if you look at the rules that I have given to you, That rule has not captured this part yet. So, on the strength of that, it will interest me to push a little bit forward because one more rule. Now, there is a rule that explains or tells us about the principal functional group and the prefix. And sometimes I can have more than one functional group in a particular compound. I can have more than one functional group in a particular compound, all right? And sometimes I can have just one functional group. In this example, I am having more than. So, moving from there, what is the longest carbon chain? What's the longest carbon chain? Longest carbon chain is a carbon chain. 1, 2, 3, 4 is a carbon chain. 1, 2, 3, 4 is a carbon chain. 3, 4, 5 is a carbon chain. So look for the carbon chain. Look for the longest carbon chain as a root hydrocarbon. So the longest carbon chain is this, and this. I just hope you can see that. So I can number it like this: number 1, number 2, number 3, number 4, number 5. The next thing I need to note is that which part is correct. Is it this numbering or this other numbering that is correct? Remember, in my numbering, I have to give preference first, first to the functional group. So you can see that the functional group here will give me the lowest possible number. If you number 1, 2, 3, 4, 5, no, it's better you not numbering it close to the functional group. So that's why this numbering is correct. So my root name will be pent. Pent. This functional group is a functional group of the carboxylic acids. This is called pentanoic acid. Now, is there anything that was not part of this longest carbon chain? Yes. That is called my side chain or my subsequent. This is my side chain or my subsequent. This one. The substituent that I'm having here to be my first. This is a and this is also a what? A functional group. When the functional group, when the functional group is acting as a substituent group or a side chain, you will name it as a prefix. You will name it as a prefix. This is alkanol. This is alkanol. What? Carboxylic. When alkanol as a prefix, alkanol will be called what? Ol. No, alkanol will be called as a suffix will be called ol, but as a prefix, alkanol will be called hydroxy because it's actually an hydroxy group. As a prefix, alkanol is called hydroxy, but as a suffix, alkanol is called ol. Now, as a suffix, as a suffix, um, this is carboxylic acid or alkanoic acid or carboxylic acids. As a prefix, alkanoic acid or carboxylic acid is called what? Carboxy. But as a suffix, carboxylic acid is called oic. You name it oic acid. So you take note of what's going on right there. So you can see that this alkanol is not part of the longest carbon chain, so it will be named as a prefix. So it will be hydroxy. And this is a carbon atom number what? Carbon atom number 3. And this alkanoic acid or carboxylic acid is also as a prefix. This is carbon atom number 3 too, but the name, because it's a prefix, it will be called carboxy. Between hydroxy and carboxy, which one comes first alphabetically? It will be carboxy. So the name of this compound is what? It will be 3 carboxy. And I also have 3, this will be hydroxy, 3 hydroxy, pentanoic acid. 3 hydrox, 3 carboxy, 3 hydroxy pentanoic acid. So we get that right now. So the second element, the second compound. So the first thing we do is that we will find the longest carbon. After finding the longest carbon chain, which is 1, 2, 3, what functional group are you seeing there? CHO. That is after now. That means the root name will be propanal. The subsequent, carbon atom number 2, 1, 2. So that will be 2 hydroxy propanal. 2 hydroxy propanal. 2 hydroxy propanal. That will be the name of that uh, compound. 2 hydroxy propanal. You see like that? Okay. All right. Let's talk about esters. Let's talk about esters. Okay. Okay, let's proceed. Esters, also called the alkanoates, or also called alkyl alkanoates. The general formulas for the ester is RCOOR prime. This is standing for the alkyl, and this is standing for, all of this is standing for the alkanoate. So in reading an ester, you start from the right hand side, and then the carbon atoms remaining comes the, the remaining, that's the alkanoate. For example, if the alkyl group here is CH and the alkyl group here is also CH3, this alkyl will be this alkyl group here. And the alkyl group is what? Methyl. And then the alkanoate is everything remaining. How many carbon atoms do you see? 1, 2, and 2 carbon atoms associated with it. So this is methyl ethanoate. Methyl ethanoate. So from there, we can push forward and say, remember, this R is the alkyl and this is the alkanoate. So what if I have CHCOO 2H5? You can see that this alkyl, this alkyl is what? And how many carbon atoms do I have here? This is two carbon atoms. That means C two carbon atoms as ethanoate. So the name of this will be ethyl ethyl ethanoate. All right. The next is what if I have what if I have C2H5 COO and then I have CH3. So I will start calling this. You know what this is? And I'll start calling this too. You know what this is. So at this point, I want to know those that stay to the end of the class. So for me to explain, this is methyl, and this is what? Ethanoate because of two carbon atoms. This is ethyl, and this is ethanoate because of two carbon atoms. You can see two carbon atoms ethyl. Now, this will be what? This will be what? This is methyl, and this will be what? This is how many carbon atoms? One, two, and three. And three carbon atom is what? Two. Now, to know those that say to the end of the class, what will be the name of this compound? The name of that compound on my WhatsApp, on my DM right now. If you okay, if you have gotten it, then I know that you stay to the end of the class. Right? Ezekiel Ekong, Ezekiel Ekong, methyl propanoate, you got it. Mighty Ekan name, he said ethyl methanoate. No, 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 he didn't get it. It is ethyl. This is ethyl. This is ethyl. No, no, this is not ethyl. This is ethyl. This is methyl. And this is one, two, three. This is propanoate. So we are not going to call it propanoate methyl. We're going to call it methyl first. Methyl first. All right. And then you call it propanoate. All right. So mighty Ekanem stay to the end of the class, and Ezekiel Ekong also stay to the end of the class. Please, can you DM me on my WhatsApp right now? Those are the only two people that stay to the end of the class. All right. If you don't have my WhatsApp number, I don't know if you're among my students. If you don't have my WhatsApp number, I'm dropping the WhatsApp number on the group as a comment right now. Yes. So that's my WhatsApp number. I just dropped it now. So please message me. Thank you so much for staying to the end of this class. I hope that you have liked my video. I hope that you have shared. I hope that you have subscribed, and I hope that you're going to recommend my channel to as many persons as possible. So message our number on WhatsApp as soon as. Thank you so much for staying to the end of the class. It will be a pleasure having live classes with you. Thank you, thank you, thank you, thank you so much. Thank you so much. See you in my next class. Like, subscribe, and share. Thank you.